Welcome back. We're going to continue our discussion on vapor pressure. This time I have chosen a specific problem where I want to point out some nuances that we did not see on the previous two problems. And the reason I chose this specific problem is simply because of the nuances that play into understanding the concept of vapor pressure. Okay, there are two primary kinds. One is when you mix a solid into a liquid. We looked at the very first problem. And then you mix two liquids, what happens? That's our second problem. This is along the same lines of mixing two liquids. Benzene is definitely a liquid. So is toluene. And you would probably see these actual compounds when you get to organic chemistry. You would see benzene, you'd see toluene. So when you mix two liquids, okay, you cannot just write one single Raoult's law, whereas you write combination, just like we looked at the previous problem in the previous video, right? So what I have in front of you is the total vapor pressure of the solution is mole fraction of benzene times the pure vapor pressure of benzene plus mole fraction of toluene times vapor pressure of toluene. Now, we only write this format when you mix two liquids. When you mix a solid and a liquid, it's just one of the single Raoult's law equation, right? Now, the question has given you the pure vapor pressure of benzene and the pure vapor pressure of toluene, which happens to be 95.1 torr and 28.4 torr. Okay. Now the question has given you the mole fraction of toluene, which happens to be 0.75. It did not give you this in the first place, and it's asking for the ratio of mole fraction of toluene in the mixture. The key word here is ratio. Okay. Now I'm going to show you two different values, so don't get them mixed up thinking that's what I'm asking. All right. So the first nuance that I meant, that the nuance I was talking about was we have something called a total mole fraction. The total mole fraction is always 1. Why? Just take my word for it. If you need further explanation, I can make a separate video for it. But this is a constant. The total mole fraction of any mixture is equal to 1. So to actually answer the question, we have to find this unknown variable first, then we can find the total pressure from which we can find the ratio of the mole fraction of toluene in the mixture. Does that make sense? All right. So if you write the total mole fraction equals mole fraction of benzene plus mole fraction of toluene, we know that this value is 1. We have to find this, so let's call it x plus this is given to us as 0.75. So if you do a simple algebraic calculation, you realize that x benzene is 0.25. Now the key trick here is knowing that the total mole fraction of any mixture containing two liquids equals 1. That's the key here, right? Now we can go ahead and substitute this value. So let's find the total vapor pressure first before we can actually answer the question. Now we know the mole fraction of benzene is 0.25 and the vapor pressure of pure benzene is 95.1 torr. Now I'm not asking you to convert the torr to ATM, and if I do, I'd be more specific. But since I didn't, you can just leave it be and 28.4 torr. Okay. So as I said, mole fraction does not have a unit, so you simply do 0.25 plus 95.1 plus 0.75 times 28.4. Okay, so it's 116.65 torr. Now this is the total vapor pressure of the mixture. Okay. The reaction is asking what is the ratio of mole fraction of toluene in the mixture. So we're going to call it just ratio equals, well, the toluenes vapor pressure is 28.4 torr, right? Right? So it's 28.4. Sorry, we got to find this vapor pressure. What it's asking is the ratio of mole fraction of toluene in the mixture, right? So you have to solve just this portion separately, which is, I'm going to highlight it in red, okay, which is this right here, okay? This portion right here, okay, you got to multiply that and divide by this total value. So that would be 28.4 times 0.75, which is 21.3 torr divided by this right here is 21.3 torr. Okay, this divided by 116.65 torr. Okay, equals 21.3 divided by 116.65 is 0.182. Okay. Okay. All right, so this is what this question is asking. So the key here is that it's important to remember the mole fraction of the total mixture is 1. Now, this is the only information I may not provide to you on the exam, something you may have to know. Now, I will give you the generic Raoult's law, and then from there you can write all the stuff, okay? So the key word here is the ratio. So you don't want to just stop here when you calculate the total. That's not what the question is asking. The question is asking, what is the ratio of this over this? And so that will be 0.182. Okay, so this is one of the problems. I do want to bring it because when you take some standardized exams, they may even just ask you, instead of ratio, let's say if the question is asking, what is the mole fraction of benzene in the mixture, then it's much simpler. It's only the word ratio that means you got to do this extra bit of math. All this math only happens when it's here. If I'm just asking what is the mole fraction of benzene in the mixture, then you just stop right here, okay, which is 0.25. How do I know it's 0.25? Because the total is always going to be 1. So you just do just this. It's only the word ratio right here. When I'm asking for the ratio of the mole fraction of either benzene or toluene in the mixture, then you go through the whole sequence and get this answer. Okay? So this is how you do this type of problem with respect to vapor pressure when you have two volatile liquids. And like I said, when you get to organic, I will show you benzene, toluene, and all these substances, and that's where this problem ends. So stay tuned for one more problem on the concept of vapor pressure.